Hello, welcome to the part 2 of this Mesa Boogie Lone Star. So if you watched part 1, which was quite a lengthy video, we did a lot of testing on this amp and we come up with a plan to make this amp more reliable and also remove the said mod that was done down here, which is this 130R resistor that's placed across the 5Y3 feed to try and reduce the bias, but we're going to remove that. We're also going to look at this top board here just to make sure there's no intermittent problems, because one time I plugged this amp in and it was dead. There was no sound, and when I pulled the socket, the speaker lead from the socket and put it in the second socket, it fired up, and when I pulled it out and put it back in the original one, it still ran. So I have a feeling that there might be a slight problem on there, so we've got to get that board out anyway, because we're going to get this bottom board out, we're going to sort this mod out, and we're going to remove the 100 ohm screen resistors and upgrade them to 1k. So that's what we're going to be doing. So we're going to start and get this board out now. You can see here we've got an array of sockets and pots and things to take off to get this board out. We've also got these leads, ribbon leads to get off as well. So we'll get those off and start stripping it down. Right, so I've got this board out too, and screen resistors all look in order, so they didn't get burnt in the tube explosion. Well, only exploded a bit inside, a bit arky. So plate, screen resistor, screen resistor, screen resistor, and then one over there in the corner there, screen resistor. Just move the camera so I'm not straining the wires. But then we've got a 1k here. That's a 4-band brown, black, black, brown 1k in series with this screen resistor, and that's going back to the feed. So if I look on this schematic here, the 100 1k, there's the feed going in there to that tube. That's got 100, that's got a 1k in series with the 100. Funny enough, I didn't spot that on the schematic. The voltage there is 354, 354. That one says 364, but that could be an error. But that one says 348, which with that 1k in, that would kind of make sense there. So I don't know what that's in there for. That's bizarre. Never seen that on an amp before. Why that one tube has got a 1k resistor in series. Don't know on that one. If we look at the board there, you can just see a slight warp in there maybe. That's obviously where it's been pinned down at this raised at, sorry, that's where it's been raised at this end. And I did think about trying to level this board up, and then it dawned on me that I wouldn't be able to do that. So when this board is fastened in, it's seated, the sockets are seated on the metal there, and that's obviously why this is level. There's no standoffs, there's just some self-tapping screws that go through, press this lip on the tube sockets down to the actual chassis. And I did think about leveling this up, but then I realised that if I did that, the metal valve retainers, the like springy valve retainers on the top there wouldn't fit the valves, because obviously if I raise this board to be level with that, that makes the tubes shorter, and the retainers wouldn't fit onto the tube, so I can't actually do that. Otherwise I might have considered putting some standoffs in there leveling that up, but there's nothing I can do with that, I'm afraid. What they'd have been better off doing is just putting that on an individual board, and I don't understand why they've not done that. Just put that on an individual board there instead of just bending it up to get to fit in there. But anyway, so I think we'll swap these plate resistors as well. Screen plate resistors, what am I on about? Duh. They're output tubes, you numpty. Screen resistors. So we've got one there, one there, one there, one there, and you can't see the other one, it's there, so it's off camera. Let's go back, there it is, hiding, all carbon comp. So it's all back together, and I've been doing a bit of testing, and also another fault has reared its head. So remember, the customer said that this amp, there was no sound coming out of it. When I plugged it in, I'd got sound out of it, and then switched it on the next day after I'd been doing some work on it, and I'd got no sound. And then I pulled this speaker socket, pulled the lead out the speaker socket, plugged it into the other one, and it fired up. Swapped them over, and it still fired up, so I just assumed that there might be a fault on there. So got this back together, I had it running, doing some tests. Suddenly the sound just went. And then I noticed that 3 of the preamp tubes were not lit. So I spent an hour and a half trying to suss out what was going on. So if we just look, just turn off. So if we look on here, you can see that we've got 2 tubes here, V1 and V2, and they're running off this 12 volt supply, so they're wired for 12 volts, but the other 3 tubes are coming off the filaments here, and you can see that they're V3, V6 on there, and V7 and V to V10 on there. So these 2 tubes are on the 12 volt DC, these 3 are on the 6.3 AC. So I did a bit of testing, and I kind of tracked it down to somewhere in this ribbon, this 11-way ribbon here. But then I switched the lights out just to see if the tubes were lit, and I saw a little arc in there. And I think probably what's happened is when the tube went dead short inside, it might have gone short to the filaments, raised the current, and maybe that's just damaged that flimsy little wire there. I mean, there's 900 milliamps running on that really for these tubes. When, you know, coming out of there, just these 3 tubes is 900 milliamps. So I've burred it back for the time being, and then I've just pushed it in, but obviously it's not in properly. It's just resting in there just to get the amp fired up, and then we've got to find a way of fixing that. Been online, looked on just about every website I can think of, and I don't see these type of 11-way ribbons, so I'm going to have to patch that up in some shape or form. So aside from that, the screen resistors, I put some 3-watt 1K screen resistors in there, and I cranked this amp on the dummy load with the oscilloscope, with the signal generator through it, and they just wouldn't, there just wasn't enough wattage in the resistors. They were getting too hot, and they were getting close to the limit of really what's allowed for a screen resistor. The problem is then to go up to the next size of screen resistor, which is 5 watts, there just isn't enough room. Now these are 563 watts that I've got in here because I've reduced them, and I'm still getting a good drop on those when the amp's cranked. But I've ordered some 470 ohm Vichys, some real high quality resistors to go in this, and I ordered those today, so they probably won't be here for 2 or 3 days. To the bias then, I've got the new tubes in, run them up on the current limiter, did some readings. On the inner 2 we got a whopping 15 watts of dissipation. Those tubes should only be at 12, so they're way over. getting hammered. The outer tubes were roughly the same, a bit less, but roughly the same. Too much. So I've dropped a couple of 180 ohm resistors in here now, and we've got a 9. Remember, these are in parallel on the 15 watt setting at 90 ohms. And then when we flick to the 30 watt, it puts a 68 ohm in series with it, but that actually measures 75 because it's gone over being a carbon comp. It's now up to 75 instead of 68. So we're going to check the bias again now, and what we're going to try and do, and I'm just really working on these two outer tubes, because they run the 15 watts, the two outer tubes, and also I have to balance them individually to the other two on the 30 watt. We're not just running off one cathode resistor, that's what I'm saying on the 30 watt. Now this 110 ohm 10 watt resistor is just not high enough resistance, but I've ordered so again some really nice resistors to try in here, and we're going to try and balance those when they come. We're going to balance the inner tubes as well and try and match all this bias up and get these tubes running cooler so they'll last longer. We'll have the screen resistors on there, so when the amp is cranked, we'll lose some voltage on the screens and the current will be regulated better, and these tubes will simply last longer, and this amp will just be more reliable. And that is the problem, you know, with this amp. It just won't be reliable running like this. You know, those tubes will run for a short time. You'd be lucky if you get 1,000 hours out of those, the way they're being thrashed. One thing thrashing the plates, but thrashing the screens as well, you know, overvolting the plate and the screen, it's a bit naughty. Just overvolting the plates is not so bad if you get the dissipation right on the tube, but when you start hammering the screens, they don't like that. And some tubes get screen runaway if you put too much voltage on them. I mean, the EL84 is a rugged tube, but even so. And the other thing is the amp's drawing a lot more current. The transformer's getting red hot. The power transformer on this, you know, I've been doing quite a bit of testing, and the transformer, it was hot. I mean, it wasn't burning your hand, but it was hot. Now, since I've put these two resistors in here, on the current meter that I've got on the wall here that we use, before I put those resistors in, this amp was drawing 640 milliamps on the 30 watt setting, and now it's drawing 610. So I know just from what I can see on there that the bias is reduced on those two tubes, and hopefully when we reduce this one, we're going to have about maybe 550 milliamps or so on there, and that means that transformer isn't working, you know, half as hard as it was before, and the amp will just last longer. You know, manufacturers they're just making amps these days that they last, you know, 6, 7, 8 years, and then they start having major problems. You know, if you're out gigging with this amp earning good money for 6 or 7 years, then, well, you could say, well, I'll throw it away and get a new one. That's not what's the case. This amp needs to be right. And what, you know, don't get me wrong, this amp is well engineered in some ways, but then not in others. So for instance, you know, these ribbons, you know, why run the filament, you know, wires through a ribbon cable like that? You've got the filament feed coming in here onto this board, feeding these two tubes here, and they just soldered those onto the pins of the tube instead of having two, you know, separate holes in the trace, so it's more secure. So they're just tacked onto there. They've had a couple of wires coming here underneath the board and tacked them onto that socket, which still, you know, you could argue is not the best way of doing it, but it'd be better than this glorified fuse wire. It's so thin. So there's some things on this amp, you know, reliability wise, but then again, I suppose if I was manufacturing amps, would I really want them to last 50 years? You're not going to sell very many, are you? So we're just going to have a look at this bias now and just see what we've got. I did do some readings on the impedance of the cathodes now because of the changing these resistors. So we've now got 90 ohms because they're 180 ohms each, and I've got 90 ohms because I've measured that. Now on the 30 watt setting, and remember we have to put this amp in standby, it has to be running but in standby to measure the resistance on the 30 watt setting, and the 15 will get a different resistance. That 68 ohm resistor, you remember, is only switched in on the 30 watt setting because you've got relays switching this. You've got to have some power on, but you can't have the HT voltage on if you're testing for impedance. So we've got 90 ohms here, but then when we switch in the 68, which is 75, we get 166 ohms. Right, so I've got the meter there, so I'm going to test from the cathode now on the add tubes to ground. Oh, I've got the current limiter on. I've only got 6 volts there. Duh. The times I do that. Right, that's better. 8 volts. 8 times 90. 8 times, sorry. Dear oh dear, I need to take a break. 8 divided by 90 is 88 milliamps. Divided by 2 is 44 milliamps. Take away 5% for the screens. 42.2 milliamps. I need to check the plate voltage, which is 268.8, or call it 269, but we've got to take 8 from that, so it's 261 times 261, and that's 11 watts. So that's what they're running at, 11 watts. Now I'm going to leave that at 11 watts, and the reason is that the wall voltage is about 238 volts now, and that will push up as much as 243, which is going to then push that up to like 11.5 watts, if not more. So that's a good window to have that in, and I'm quite happy with that. And that's a damn sight better than the 13 or 14 watts we had before, so that's really good. So now those tubes in the 15 watt are running cool. No need, if we just come back, there was no need for this bias mod here, and we've cleaned that up, and we forgot to have a look at that, but we'll have a look. No need for that bias mod. All you need to do is change the cathode resistors, and cutting through those tracers on that board there, it was just totally unnecessary. All I've done is put a couple of 180 ohm resistors in there, remove the hundreds, put the 180s in, and that sorted it. Furthermore, if somebody could have paid for that mod, it's obviously took a considerable time to do. Swapping those is just easy. I don't understand it, but anyway, what do I know? So that's the 15 watt setting sorted out now on this, and we've got that running cool. So just how we like it. So I've got these resistors just tacked in at the minute, so obviously I'll cut the legs short, put them in properly. And they're not even hot. Well, they are a little bit hot, but I can keep my finger on them. So yeah, they're 3 watt resistors that are in there. So that's good. So now we need to go on to the 30 watt setting, and we need to be pretty quick taking the readings on here, because those other tubes, those outer tubes, inner tubes, are running at 15 watts at the moment. So let's measure the 30 watts. Flick onto there. 12.6. Flick back onto the 15, because I don't want to keep that. Like I said, those inner tubes are running at 15 watts, and I don't want to turn the paint on the new tubes. Let's do the maths on that. Now we've got 166 ohms for that. So 12.8 divided by 166 That's 77 milliamps per tube. Divide by 2, that's 38. Take away 5%, that's 36.6 milliamps. That sounds much healthier, doesn't it? Instead of about 50, which is what it was before. So we just need to get some plate voltage now. 275. Let's just flick onto the 30. So 345 less 12, 333 will do, won't it? And that's 12.19. So they're on the money. Just a tad over, but that's fine. So now the wall volts is at 242 volts. Getting ever closer to the 243 I always see. We've got 11 watts on the 15 watt setting, and we've got 12 on the 30 watt setting on the outer tubes. I'd call that a wrap on that. That is perfect, exactly where I want that to be. Quite happy with that. And yes, the plate voltage is a little higher, but it's not excessively high. I've seen much bigger voltages on those plates, much bigger voltages, so that's fine. So we've got that sorted, but unfortunately the other side we haven't. But I don't have any 10 watt resistors. I do have some ohmite ones, but I think they're too big. Yeah, 250 ohms, that's too much. At the inner tubes at 30 watts. So if I flick onto there, 11.5, just flick back off there, 11.5. Divide that by 111, because we know that resistors that. So those two tubes are running at 103 milliamps. So if we divide that by 2, 51 milliamps. 5% for the screens, 49 milliamps those tubes are running at. The others are running at 36. So the outer tubes now running at 36. The inners are running at 49.2. And the plate voltage should be about the same. I think 341 less 11 is 330. And now the voltage is up like 241. It's just dropped a bit again now. 16.2 watts they're running at, baking them, absolutely baking them. Earlier when I took that voltage on the wall voltage was about 234 and it was 15 watts. Now it's 16 watts. That's 4 watts over, so they're not going to last long. But we're halfway there with the bias. So I've just checked that order and I haven't got 160. I've ordered 150 and 180. Couldn't get a 160. The screen resistors just come down. So as I say, I've only got these tacked in for testing at the minute. So the screen resistors that are 470 ohms and their maximum temperature of 230 degrees and their 500 volt rating. So the high performance resistors, only we have some good quality in here. I don't want to be putting these resistors on the screens. They're okay for testing, but they're not good enough to go in this amp permanently. Good enough for testing. But I couldn't get any 560s, so I've ordered 470s. It's close enough. There's not that much difference. Right, I've got the amp on a dummy load now. I've got this meter measuring the drop across one of the screen resistors on the outer tube. We're in the 15 watt setting, and we can only do this test on that because obviously we don't have a bias resistor for the inner two tubes yet. So I've got the signal generator going through it. I've got a 2.4 volts drop on there, and I've measured the screen to cathode voltage. It's 261. So now I'm going to start to turn this up. you can see that voltage beginning to increase. Just put that on there, and now we've got 6.5 volts across that resistor, which is 560 ohms at 3 watts. And you can see now, cranking the amp up, we've now got 10 volts going across there. So now we've dropped the screen voltage by 10 volts. Now that this isn't a huge deal on the 15 watt setting, because we're already below the 300 watt rating for the screens anyway, because we're only running on that 5Y3. But it'll give us an idea, just give you an idea of what these screen resistors do. So you can see we've got that 10 volt drop, and this is how with these screen resistors, we need to make sure that they're going to hold up. It's all right putting them in when it's turned down, and just to give you an example, we'd got a couple of volts, say 2.5 volts, when this amp was idling. So if I 2.5 times 2.5, divide that by 560, we virtually, you know, we've got like 0.1 of a watt. But as this gets turned up now, and that increases, I'm getting a bit of oscillation. I don't know whether that's the generator that's doing that. So turn this flat out now, and you can see that voltage is now creeping up towards 13 volts. And there. And now, so we'll just say that's 14 volts. So 14 times 14 divided by 560. Now that resistor is 0.35 of a watt. So still under there, but that will be getting warm. And this is why we need good quality resistors in. But on channel 2, so if we turn that back down, on channel 2, we're on the 15 watt setting, so we go on to channel 2, and we're on the drive setting, and you can see that now going up. Remember, we're only on the 15 watt setting here. So on the drive setting, we're about the same, 13, 14 watts on that 15 watt there. And obviously now this is, I actually tested this earlier when I was working with the resistors, and this is actually much lower now because we've simply got less current, less screen current, because obviously we're not drawing 13, 14 watts of dissipation on the tubes. Increasing the cathode resistors to reduce the dissipation on the tubes has now reduced the current on the screen resistors. Flick it off the drive. You can see that's dropped it down. So with the 1K resistors in and the bias with the test tubes in, because the bias was running quite high with the test tubes in, we'd got those resistors were on the limit. They got to 1.92 watts and they were only 3 watts, and they were cooking. So even though, you know, you really want a good bit over, almost double over really, so a 4 watt resistor would have been ideal for that. And obviously these are test resistors. These are resistors I use for testing, or just in smaller single-ended amps, or 15 watt, you know, single-ended, not amps of this caliber that are drawing this, you know, sort of current. So some good quality resistors, screen resistors in this, it's imperative. So we've got those on order. Right, got the amp back together. Got the resistors here for the bias on the 15 watt setting. They're now soldered in properly and done, lifted off the board as they should be, because if they burn up they'll take the board with it. We've got the screen resistors in here, here and here. These are those Vichy ones we ordered, and they're lifted off the board as well, and they're far better up on the top here than underneath because they've got air around them now. Shouldn't really put screen resistors under a board. It's not a good idea, I don't think. Right, let's just have a look at one of these screen resistors. Switch the amp off a minute, because if I drop this resistor into there while we're testing it, so you can see there that they're the ones we're using. I think it's upside down. Read it now. So they're the Vichy ones. These are rated at 500 volts, very high temperature, 230 degrees. That's those then. Now I've got a 150 ohm resistor tacked in here at the moment. That's a 10 watt, and we'll have a look at one of those as well, but I don't think it's going to be enough. Also, they're a bit heavy duty on the leads. I'm not sure whether they'll go through the holes. I'm hoping they do, because I've just tacked it on to the remaining leads on the other one to start off with, and obviously that's not good enough. That's okay for testing. Another problem is the soldering terminal is right at the side of this relay here, this switching relay thing. Nightmare, absolute nightmare. And we've also we're going to have to raise that resistor off the board as well, and we're going to have to be careful that this ribbon cable doesn't fall onto it, because if ever that resistor burns up, it'll burn straight through that. Now I've also repaired the filament. We'll have a look at that in a moment. So let's just look at this resistor, and that is the beast that we've got in there. Now what I've done on this, and I have to say I'm not happy about repairing this way. What I would have liked to have done was taken out this board, soldered on some wire of this caliber to the pin, to the terminals on this socket, and then brought it out to a tag strip on here and wired it all up. But obviously taking this board out is a massive job, and also a very expensive one for the customer. So what I've done is I've joined this here with some of this cable, which is slightly thicker than the one they've got in there, and I've joined that. I've had to make it up because it's not long enough, and then I've pushed it in like these. They've got like pins in there. I've had to fish the old wire out, push it in. It's worked okay, but I don't like the whole idea of this. That's the thing. I just don't like it, but it's worked and it seems reliable enough, so hopefully that will hold up. If not, then the board will have to come out, because I can't find one of these ribbons anywhere. Right, so I've got this amp more or less biased. I've got one resistor that I've ordered to alter, and I want to try and bias them at 11 watts. But I've been running the amp. I removed the 75 ohm resistor, which is actually 68, but it measures 75, and I put 100 in there, and I need a 90 to balance this up. But I'm running it with the 100 ohm resistor in. It was running absolutely fine, no problems. Checked everything out on it, playing the guitar through it, and suddenly I thought, this don't sound very nice. Looked at the current meter on the wall, and I've got this running at 540 milliamps on the 30 watt setting. It was running at 640 before I biased it, and suddenly it was up to 670. I did a quick measure across the cathode, and I'd got 18 volts across these cathodes. Now I'd got about 12 volts across the cathodes before, so I've found 6 volts from somewhere. This tube, it's turned the paint. So I looked at that tube and thought, well, that's got hotter than the others. So I put old set of tubes in it, the old set that we was using, 2 of those are the customers, 2 are my test tubes, run absolutely fine. So I put the JJ in that the paint had turned with those old tubes. It run fine. So I've now put the JJs back in. It runs fine. They're all in the same sockets. It runs fine. It's now been running for the best part of 45 minutes. And it's still at 540 milliamps. The only difference before to it running now was it was facing PC board up. Now it's facing PC board down. So when it's facing PC board up, the heat is rising and making the PC board warmer. I've got a suspicion that the filament voltage is leaking into the cathodes, because when I looked at that board, the filament trace is running really close to the cathode pins, and I mean really close. So I'm wondering if that's what's happening intermittently, and I'm wondering if that's why the customer had the problem with the tube blowing before. So I don't know. It sounds great in playing through it. Checked it on the scope, no crossover distortion, all runs fine. Had it on the scope on a dummy load, cranked it up flat out, checked the new screen resistors, that they were running, they take the current, no problem. Everything was running fine. It was running flat out for about 10 or 15 minutes, nothing. It just worked absolutely perfect, no problems whatsoever. And then all of a sudden we've just had that runaway of the current. Right, so I've done some more testing, and this amp was running for a while again. I flicked after it had been on 10 minutes, I flicked the channel switch down onto channel 2, and the surge of the current sent the tube on this side into red plating. This outer tube here sent it into red plating. So that tube was faulty, and I was beginning to wonder whether we got some leakage on this board, but it's turned out just to be that tube. So swap the tube, all good, and the 90 ohm resistor we was waiting for has arrived. We've put him in there, and that's given us an impedance on the outer tubes of 179 ohms, and we'd got 178. This was 180 ohms, we got 178, so we've managed to match those up pretty perfectly there, I would say. And the bias now is 11.4 watts on the outer tubes, and we've got 11.6 on the inner tubes, so that's absolutely fine. Perfect match there, so all good. And the Boogie, or Boogie, or however you want to pronounce it, is finished. It's all done. So we're going to get it in its case, and we're going to have a blast on it. Right, we've got the Boogie, and we're going to see if it boogies. So we're on channel 1. We're on the 30 watt setting. Clean tone there, so if I'm just going to push up this gain, bring the master down, just thicken it up a little bit. So that's the clean channel. Let's go on to the overdrive, or channel 2. Oh. Channel 2, there we go. And we're on the drive. Let's crank the drive up. There's a bit of activity going on in here. There's a fly in here, and Pink has decided it's public enemy #1, and so has the dog. There's a bit of a competition going on. The dog keeps leaping up the front door, and you might be able to see Pink in the window if we just hone round. Is she in the window? Yes, she is. She's waiting for it to land. She's waiting for me to pull the net back so she can get it. And she usually does get them. And all hell is breaking loose. I pulled the net back and the fly was immediately eaten. And now I've trained Pink, so she's now going to wash the fly down with 20 Dreamies. Go. Dog's got to face like a bulldog chewing a wasp because he didn't catch anything, so if he's not got anything, we'll give him something later. You'll all think I'm mean. Anyway, back to this amp. Dear me, can't get anything done here. Right, so we're on the overdrive, weren't we? We got a bit too much reverb. The controls for the reverb are on the back. Let's let's just wind the gain up on channel 2 as well as the drive. So onto the 15 watt setting. There's a bit of locking distortion. Take some bass off there. Back to channel 1. Yes. Very bright, this guitar, and I'm not used to playing it. I haven't played this guitar for not only in that altered tuning. I've actually strung this up, as you can see, for standard tuning. You've probably seen this in a couple of the videos. I've had this guitar since I was 16. What are you doing, Pink? Stealing again? I think I'll just put those over there out of the way. Right, let's go on to the 5 watt setting. Let's go on to channel 2 on the 5 watt setting. That noise you can hear is the Dreamy's being ripped open because Pink thinks she's been shortchanged for catching the fly, so she's helping herself. Right, so there we go. So that's the Boogie. All done and dusted, and we've had a few problems with this one, but we've got there in the end. Take those off now. So that'll do it for this one. So thanks for watching. You all take care, and I'll see you all in the next one. Bye bye for now.